morning and welcome to CTTC Adrenaline Network series of demos. In this first demo we will show the GMPLS controlled wavelength switch optical network, which is the basis of our research work. We will also show the developed applications that allowed us to establish, manage and release optical connections in our testbed. The testbed is composed of 4 optical cross connects interconnected with up to 600 kilometers of optical fiber. Each node in the Adrenaline testbed is composed of a GMPLS control plus an optical switch. Optical switches can be optical cross connects or XC or reconfigurable optical ad-hoc multiplexers for ROADMs. These elements are able to switch the signal based on a wavelength. That is, they switch the wavelength from an input port towards the wavelength towards an output port. Our first application is the Adrenaline Network Configurator tool, also known as AdNetConf. AdNetConf is a graphical user interface application which allows the researchers to define the network scenario that they want to research on.
AdNetConf is a fundamental tool for an engineer's daily work. AdNetConf permits to evaluate algorithms on the control plane.
The AdNetConf application is able to carry out several operations on the testbed, such as deploying the scenario, monitoring the scenario, or checking down the status of the network. The actual use topology is a 4-node topology with 6 optical links. Each optical link has 6 or 12 wavelengths.
We can see how the photonic network has been configured. The control plane are software programs which are running as daemons inside the corresponding node. In this sample configuration, we can observe which are the used processes in the control plane. Another important parameter to choose is the number of available wavelengths.
Once the scenario has been deployed on the actual testbed, the AdNetConf application allows us to monitor the status of the control plane processes, the status of the link, and the status of the network as a whole.
The monitor process executes a group of processes, like ping, that verify each node has connectivity towards its neighbor, and that the control plane processes are correctly running. Once we have verified that the processes are running correctly, we can start experimenting with the deployed scenario.
Once the scenario has been deployed on the testbed, we can use the second application, which is the Adrenaline Network Traffic Generator, also known as AdNetGen. This second application allows us to load the scenario that has been deployed and to establish and release connections either manually or using some batch of connections.
A connection example is Girona-Tarragona. Girona is the entry node, the origin point. Girona has asked for the optimal route from Girona to Tarragona. OSPF computes the route and runs that there is continuity in the light path, and with the RSVP protocol, the reservation protocol, we signal the reserved route for Girona. If we analyze the link status, we can see how a light path is occupied.
Using the Wireshark network analyzer, we can see the traces of the main control plane processes and protocols, which are RSVP-TE and OSPF-TE. We can see here the hello messages being exchanged by the GMPLS controller.
Using Wireshark, we can observe how the protocols run. Once the origin node has a route, it disseminates it using path messages and announces the reservation through res messages. Once the connection is established, there's an update message from OSPF, who disseminates to the whole network the new state.